And here, and they take the any real number a times 1 is a, and also we know that 1 times a also a. It's okay. So let's consider the matrices and take the matrix a n by n. A times identity matrix is equal a, and also identity matrix times a is equal a. But here be careful. And this one it is true, and a is n by n matrix. This one is n by n. And let's write here. Sorry. Take here a times identity matrix. This one is a. Identity matrix times a. It's okay. So a is n by n matrix. A is n by n matrix. N by n. And so this one is product. So this multiplication is defined because gives matrix A. So, and this one should be, what's the dimension? Identity matrix. The dimension of identity matrix should be n, the row, the number of rows is equal to this one, should be. And also the result matrix n by n. So this one should be n by n. Okay. So, and the sub-index here should be identity matrix order n. It's okay? N by n. But here be careful. A is n by n. This product gives a. This one is n by n. So what can you say about it? If this one is n by n matrix, so n is not equal m. So this one is undefined. But we claim that this product gives a. So this identity matrix not order n. And this one should be order m. Otherwise undefined. Because a is n by n. This one is n by m. So we obtain result n by n matrix. So be careful. This one is valid. Yes, is okay. We can omit the sub and the n and m, but we know that if we know the definition of the product, we know that this one should be identity matrix of order n. This one is the identity matrix, but different from this identity matrix. Order should be n. Otherwise undefined. Be careful. It's okay. Let's come back. This one. It's okay. Any question here? Okay. Now, first of all, for example, and to see that this one, this one, and take the matrix A. A is dimension 2 by 3, 2 by 3 matrix. So 2 by 3 matrix. So identity matrix should be, this one should be 2 by 3. So this one should be order 2. It's okay, this one. But look at the other side. Take the A times identity matrix. A is 2 by 3. And this one should be, we know that identity matrix square matrix. So this product is defined. So this one should be 3 by 3. So identity matrix order 3 should be. It's okay? Yes. Now let's define the powers of any matrix, but be careful. And here A is square matrix should be. Square matrix, first of all. P is a positive integer. Positive integer. It's okay. Positive integer. Let's define the power of a matrix. And let's define the A to the P. A to the B. What does it mean, A to the P? A to the P is equal A times A times A. The number of A's, A, P. Is okay? And here should be square matrix, because what is the reason? For example, take A is n by n, not square matrix. So let's look at the A to the P. A to the P means take the A, multiply by A, and A times A. And the number of A is P. But look at this one. This dimension n by n. A is n by n. This one, this operation product. And also n is not m. So this one is undefined. Undefined. So means if our aim is to mention the power of any matrix, A should be square matrix. Otherwise, undefined. This one. It's okay? Be careful. Should be square matrix. So now take the two non-negative integer p and q. It's okay. So and what's the a to the p, a to the q is equal a to the p plus q, and this one is equal this one. And also let's come back here. A to the 0. What is the A to the 0? A to the 0. If A is square matrix, A to the 0 identity matrix. If A is n by n, this one is identity matrix order n. So here, and the critical point, be careful. What is the A times B to the P? This one is not equal A times B, take the power P, A times B to the P, and let's compute this one. A times B to the P means take the A times B, first one. The next one, A times B. Next one, A times B. What's the number of AB? P. It's okay? So, look at this one. We know that, let's come back, and the multiplication is associative, this one. It's okay? It is not important in the parentheses, and so write this one, A times B, A times B, A times B. So, and it is not possible to write this one, B times A is equal A times B. If is equal, yes. So write here A, and B times B times B. Is okay. So the number of A is P, the number of B P. So we obtain A to the P, B to the P. But here, and false this one, because what's the reason? And here we know that and product is not commutative. B times A is not A times B. So A times B to the P is not equal this one. It's okay? Let's come back. This one, it is not true. Not true. It's okay, square matrix. Power, of course, is valid and to define and the square matrices, but here in general, this one, it is not true. If, and take the commutative and the matrix, if we know that A times B specific matrix, take A and B, B is equal A, yes, it's true. But in general, it is not true, this one. So this one is not equal. It's okay. So, and now let's define the transpose of any matrix. What is the, and take the any matrix, it's okay. For example, n by n matrix, it's okay. N by n matrix, A. Let's define the transpose. What is the transpose? Transpose is denoted by A to the T. Transpose of matrix A is okay. And if our matrix n by n matrix, so transpose matrix should be n by n. Change the order. It's okay, matrix. But our aim is to define the transpose matrix. So first step gives the dimension. Dimension should be n by m. So the next step, determine to determine entries. What's the entries? Entries of this matrix is equal ij entry should be ji entry, the corresponding ji entry. It's okay, of the matrix A. And what does it mean, this one? And take the matrix A, change the row and column. It's okay. And what does it mean? Let's give an example to understand. Take the A, B, C, and D. Write the transpose matrix of each matrix. It's okay. Matrix. Each matrix. So A is this one. What's the transpose matrix? This matrix, 3 by 1 matrix. So transpose matrix should be 1 by 3. So this one contains 3 rows. So first row will be first column. Second row will be second column. Third row will be third column. It's okay? And change the row and column. We obtain the transpose. First row will be first column. Second row will be second column. It's okay? So this one is 3 by 3. Transpose also 3 by 3. First row, first column. Second row, second column. And the last row gives last column. So this one, first row will be first column. It's okay? Any question?
Hocam ekranınız takılı kalmıştı da sanırım göremedik en son yaptıklarınızı.
Şu anda
Hocam şu anda the transpose of a matrix kısmı gözüküyor sadece.
o zaman şey yapalım. Ekranı tekrar paylaşıp açalım donduysa arkadaşlar. Belki onlarla düzelir. Şimdi görüyor musunuz?
Evet hocam.
Örnekleri göremediniz o zaman değil mi arkadaşlar?
Maalesef.
O zaman yeniden tekrarlayalım. Let's consider these matrices. Let's write the transpose matrix. And the first matrix A contains only one row. And the first row gives first column. It's okay. And the transpose of B is 2 by 3. And the transpose should be 3 by 2. And the first row will be first column. Second row will be second column. It's okay. And the C is 3 by 3 matrix and transpose 3 by 3. First row, yes. First row, first column. Second row, second column will be, and the last row will be last column. And the last one, D, 1 by 3 matrix, transpose should be 3 by 1. Yes. First row will be first column. It's okay. Any question? Okay. No question. Okay. Now, let's give the property of the transpose. It's okay. Transpose. And here. And the first one, yes. What can you say about the transpose of transpose? Take the transpose of A and apply the transpose, interchange row and column, and then transpose of the result matrix. So gives, yes?
A itself.
Okay, A, you are right. 2. Second property, take the 2 matrix, appropriate sizes. It's okay. So, and look at this sum, and this sum gives the matrix, one matrix. So, and take the transpose of the result matrix. So, what can you say about this one? Transpose of the sum is equal sum of the transpose. A to the transpose and B transpose of B. It's okay? Transpose of sum of transpose. It's okay? So the next one, take any real number. It's okay. And the matrix A and also R times A. R times A we know and from the first lecture. It's okay. From Monday. And the scalar multiplication operation. Look at these matrix. A is a matrix. R is a real number. This one is scalar multiplication. This one gives a matrix. It's okay. So take the transpose. So what can you say about this one? R is a scalar, and then this one is R times A to the transpose. Means, first of all, here, left side, compute to this scalar and then take the transpose. But here, first take the transpose and the next one multiply by R. It's okay? Is equal. So, the next one and the last property for take the two matrix AB, appropriate size, and this product is defined, and compute to this product, and we obtain the new matrix. Take the transpose. So, what is this one? What can you say about this one? Transpose of product of transpose is equal. This one is true or not? Yes. This one is true or not? Any idea?
Not true.
Not true. Not true. So is equal. Yes. Right side should be. This one it's not true. It's okay. So question is equal to transpose of B, transpose of A. It's okay. Order it is important. And change the order. It's okay. And this one it is not true. Be careful. It's okay. Let's see that. Let's look at this example. For example, this one is true. It's okay. This one is true. So take the matrix A, for example, matrix P. It's okay. So compute the A times P. A times P this matrix. Take the transpose. It's okay. Transpose means change the and first row will be first column. The second row will be second column. Yes, this one. So let's compute the right side. Transpose of B. B is this one. First row will be first column. Second row, second column. Third row, third one. Transpose of A, this one. So we obtain this matrix, transpose. And compute to this product, and so we obtain under this one. Yes, look at the right side. Sorry. So This one is equal this one. So means this one is equal this one. It's okay? But compute the homework transpose of A times transpose of B is not equal this matrix. It's okay? Be careful. Any question? No question. Okay. Let's come back. Let's define the symmetric matrix. It's okay. Symmetric matrix, take the matrix A. It's okay. A, and the symmetric matrix, if take the transpose, if, and the transpose of A is equal to A, and we can say that A is a symmetric matrix. What is the symmetric matrix? And so what can you say about A should be square matrix? Otherwise, take the transpose, interchange row and column, but is equal to the same matrix. It is not possible because dimension should be same. So A should be square matrix. Otherwise, and this equation, it is not true. It's okay. So, and A is, if our matrix is a symmetric matrix, A should be square matrix, first of all. And also, and every entry, ij entry should be ji entry, should be. Because first row will be first column, the second row will be second column. It's okay? So, what does it mean, this one? And means, look at the matrix A. Our matrix A here is okay. So, and the first, for example, take the ij entry. It's okay. And this one, for example, here, 1, 2 entry. This one is 1, 2 entry. So interchange the row and column. And so this entry should be 2, 1 here. The same should be. So means if our matrix is a symmetric matrix, look at the main diagonal. So, and every and here the elements of A are symmetric with respect to main diagonal. And means, look at this matrix. This one should be, sorry. This one should be same. This one should be same. It's okay? Symmetric with respect to main diagonal. So let's give an example. Look at the A matrix. Look at the main diagonal. It's okay? So this one is symmetric or not? Yes. 2, 2, 3, 3, 5, 5. This one is a symmetric matrix. Look at this one. Identity matrix is symmetric. Yes, 0, 0, 0, 0, 0, 0. Because what is the reason? Look at this one. A transpose of A is equal A. Identity matrix transpose, take the transpose, gives identity matrix. It's okay? Yes, let's end the last concept, skew symmetric. Skew symmetric matrix, and means transpose of A should be minus A, and means every entry ij entry, ji entry minus ij. So, and so transpose of A and A should be the same size, it's okay, and it should be square. So, what can you say about, for example, let's construct the skew symmetric matrix. For example, 1, 2, 3, 4, 5, 6. This one should be square, not A. This one is B. Our A, this one should be skew symmetric matrix. What can you say about this entry? Yes. Transpose of A minus A, and every entry should be minus ij entry. Yes, any idea? Yes, please.
-2, -3, and -5.
minus 3, minus 5. This one is skew-symmetric matrix, okay? It's true?
The main diagonal does not apply for this rule, I think.
Yes, it is not skew-symmetric. So, how to transform into the skew-symmetric? Yes?
The main diagonal should be 0, I guess.
Yes, you are right. Thank you. This one should be 0, 0, 0. Otherwise, because here for all ij, so b sub 1, 1 should be minus b sub 1, 1. And b 2, 2, main diagonal, this one should be minus b 2, 2. But we know that entries real numbers. Which entry should be and itself multiplied by minus 1? 0. It's okay? So means skew-symmetric matrix, the main diagonal entries should be 0. It's okay? Yes, any question here? No question, okay. Let's stop here.